All right, let's dive right in. Today, we're going to be clinical detectives, and our very first clue, it's one of the most common things you'll see on a microbiology report, ampicillin resistance in Haemophilus influenzae. Now, it looks simple, right? But trust me, that one little letter R is hiding a much, much deeper story. So picture this. A lab report lands on your desk. You're scanning down the page, and there it is, Haemophilus influenza, with a big, bold R right next to ampicillin. Your first instinct, your reflex, is to switch to amoxicillin-clavulanate, right? I mean, that makes sense. But what if that's the wrong move? See, that one R isn't the answer. It's just the start of our investigation. So here's how we're going to crack this case. We're going to break this whole problem down step by step. First, we'll look at why this is such a common headache. Then, we'll uncover the two totally different types of resistance hiding behind that one R. We'll zero in on the role of clavulanate, figure out how to tell the two types apart, and finally, lock in how to choose the right treatment every time. Okay, so let's start with the problem itself. That big R for resistant next to ampicillin, it's a critical piece of information for sure, but it's also incomplete. It tells us what the problem is, but it doesn't tell us why. And you know, in microbiology, the why is absolutely everything. Think of it like this. The resistance you see on that report is like the final chapter of a story. But here's the twist. That story could have been written by one of two completely different authors. And if we want to treat the infection correctly, we have got to figure out which story we're actually in. So who are these two authors? Well, they have some pretty specific names, BLPR and BLNAR. Getting to know these two is the absolute key to solving this whole puzzle. First up, let's meet BLPAR. That stands for beta-lactamase positive ampicillin resistance. These bacteria, they've got a weapon. It's an enzyme called beta-lactamase. The easiest way to think about it is like a tiny pair of molecular scissors. Before ampicillin can even get close to attacking the bacteria, these scissors just find it and snip! The antibiotic is literally cut apart, making it totally useless. Now, for our other suspect, BLNAR. That's beta-lactamase negative ampicillin resistant. And this strategy is way sneakier. These bacteria don't bother with the scissors. Instead, they've changed the antibiotic's target. So if ampicillin is the key and the spot it needs to hit on the bacteria is the lock, BLNAR bacteria have simply changed the lock. The key just doesn't fit anymore. And this slide just lays it all out nice and clear. For BLPR, the mechanism is that enzyme, the problem is a destroyed antibiotic, and yeah, the solution is usually amoxicillin-clavulanate. But then you look at BLNAR. The mechanism is a mutated target, the problem is the antibiotic can't even bind, and here's the real kicker, amoxicillin-clavulanate is often completely ineffective. And you can see it visually right here. On the left, you've got the BLPAR strategy, just pump out that beta-lactamase enzyme. And on the right, the BLNAR strategy, a quiet little mutation in the PBP3 target site. See? Two completely different paths that both end up at the exact same destination, ampicillin resistance. This brings us to the hero of our story. Well, at least half of it. Clavulanate. It's the clav in amoxicillin-clavulanate, and its job is very, very specific. This quote, it just summarizes everything perfectly. If the bacteria are using those scissors to chop up amoxicillin, clavulanate comes in and jams them shut. Simple. But if the bacteria have changed the lock, clavulanate is useless. It can't pick a new lock. So the bottom line is this. Clavulanate is a beta-lactamase inhibitor. Its entire job is to stop that enzyme. And by doing that, it brings amoxicillin back to life against BLPR strains. But, and this is a huge but, against BLNAR strains, which don't even use that enzyme, it has absolutely no effect on that altered target. This is exactly why just automatically switching to amoxicillin-clavulanate can lead straight to treatment failure. Okay, so theory is great. We know there are two types, and we know clavulanate only works on one of them. But how do we, as clinicians, actually figure out which one we're dealing with in the real world? Well, thankfully, there's a pretty clear strategy. It really just boils down to a simple two-step process. First things first, check if the lab ran a direct beta-lactamase test. I mean, that's your smoking gun right there. If they didn't, then we have to play detective and figure out the answer from the other antibiotic results on the report. So let's break down those clues. If that beta-lactamase test is positive, boom, it's BLPAR, case closed. If it's negative, but ampicillin is still resistant, then you've got to suspect you're dealing with BLNAR. And here's a fantastic pro tip. Look for cefuroxime or CXM on that report. If the bacteria is still susceptible to it, that's another really strong clue that points right back to BLPAR. All right, time for the final act, putting all our detective work into motion. We've figured out the culprit, and now it's time to choose the right weapon to make sure our patient gets better. This chart really makes it easy. If you've got a mild or moderate infection, say a typical sinus infection, and you suspect BLPR, amoxicillin-clavulanate is a great choice. But if the infection is severe or the patient just isn't getting better, or you know that BLNAR is really common in your area, then you have to level up. That means picking something more reliable, like cefuroxime or ceftriaxone. And here it is, the single biggest takeaway from our entire investigation. That R next to ampicillin, it is not an instruction to just prescribe amoxicillin-clavulanate. It's a question. And your ability to answer that question, to figure out if you're up against BLPAR or BLNAR, is what will determine the right treatment for your patient. So I'll leave you with this little food for thought. We know that BLNAR is on the rise in a lot of places. So as that trend continues, how is that going to change our standard first-line antibiotic choices for really common infections? It's a critical question, and it's one we're all going to be facing.